Welcome to Translogic. I'm Bradley Hasemeyer. On our show, we've checked out many forms of transportation, but one we often take for granted is our own. So today, we're at the University of Michigan to meet a machine that can both run and walk like a human. Meet MABEL. We are here at the University of Michigan at the MABEL lab with Professor Grizzle. Thanks for being with us, Professor.
Thank you for coming.
So tell me a little bit about how MABEL came to be.
It was total serendipity. I was on sabbatical in Strasbourg. I met up with a group of people getting ready to build a bipedal robot. They needed a feedback specialist. That was my area, and so I started hanging out with them, and one thing led to another. And then when that project kind of finished up, we decided we should have a robot here at Michigan, and MABEL was planned in 2004, 2005.
We've seen a few other robots out there. There's Asimo, there's Big Dog. How is this different than those?
The thing we're working on here is to try to have very dynamic stability under quite extreme situations.
My objective with MABEL is walking over very rough ground without any information about the terrain.
It has very large springs on it. The springs allow it to absorb very large shocks. And the springs are connected to the motors through a set of cable drive differentials. They store the energy from the impact at the initial part of the gates. That could last 150 milliseconds or something like that. But then you get that energy back at the end of the step.
Why did you guys decide to go bipedal?
Part of that is people respond to robots that are a little bit like them. So the anthropomorphic nature just makes it more exciting. Also, the mathematics and dynamics are such that things you develop on a robot like MABEL can have spin-offs into exoskeletons to help the disabled walk, prosthesis design, etc. The second thing we're trying to do is get the mass distribution such that the center of mass of the robot is high, up above the hips. This is because when you eventually deploy robots in some sort of realistic situation, you're going to be putting gear on them. If you try to mount that stuff around the hips and keep the center of gravity low, then all your gear is going to be interfering with the leg. You want that up high on the body, just like people put backpacks on and stuff. And that brings us also to the fact that MABEL has no feet. If you put a big enough foot on anything, it'll actually stand up. You probably have lamps in your room. They have a base. They stand up just fine. Hey, no feedback control required. So if you look at a lot of the robots out there, they put huge feet on them, and they're walking flat-footed. Whereas if you're doing a point contact like MABEL, what you're doing is emulating how people walk, where they have a heel strike,
and it's a roll.
Roll forward, then you roll on the toe. This gives us a nice under-actuated motion that allows us to prove we're doing true dynamic balance. It really sets what we can do on MABEL apart from many, many other robots out there.
So explain the boom as it's connected to MABEL.
What the boom does is just gives the side-to-side stability, but it doesn't support it up and down or forwards and backwards. The hips only move in one direction. Our hips move forwards, backwards, they move side to side, and they have a twist motion as well.
So it essentially locks in at least one variable so you guys can work on some of these other aspects too, right?
Precisely. I mean, it does simplify the mathematics. It also makes the robot safer, because you know exactly where it is. It has to walk in this circle. If you're outside the circle,
you don't want some X-Files thing where it just takes off and it's going crazy in the room.
That would probably be the last experiment we were allowed to do on the robot.
There you go, dancing with MABEL.
And what excites you about MABEL?
Bipedal locomotion, it's a cutting-edge technology. The thing that I'm always proud of is giving that agility and dynamic motion to a system like MABEL, which is very complex, is not very easy.
So what's next for MABEL? Where do you guys go from here?
Well, actually, what's next is a new robot. Its name is Atreus. It means assume the robot is a sphere. This robot will not have to have a boom. Its hips will be able to move the legs forwards and backwards and side to side. So it'll be an indoor-outdoor robot. So what's next is doing the full 3D gate, so three-dimensional space. It'll be battery-powered with a wireless interface. It's going to be super cool.
That's exciting. What, do you guys have any kind of project deadlines for that? Like, are we looking at 2014 or?
Well, in principle, the robot should show up here at Michigan around August of this year. We'll be then taking all the knowledge that we have from MABEL and applying it to this new robot. We're really looking forward to that challenge.
There you go. She can walk, she can run, and she's getting better every day. And the research from MABEL can have great implications in medical prosthetics, military, and safety and rescue. All right, for Translogic, I'm Bradley Hasemeyer. See you next week.